Howdy, this is your friendly neighborhood physics teacher here, and these are your wave calculation notes. So we're going to go over how to solve for wavelength, velocity, frequency, and period. So let's start with our equations. So our first equation we're going to talk about is wavelength equals velocity times frequency. You can make that into a triangle since there's only three. Your wavelength goes on top, velocity, and frequency. And if you cover up your velocity, you'll see that velocity equals wavelength divided by frequency. You cover up your frequency, and you see that frequency is wavelength divided by velocity. You can sit there and manipulate your equation that way. You do have another few equations for frequency. Frequency is 1 over your period. Period is 1 over frequency. Now, what that is, if you remember the definition from your notes about frequency, frequency is the number of oscillations in 1 second. So it'd be another way of saying it is cycles over 1 second. So it'd be another way to figure out, number of oscillations, number of cycles, number of vibrations. So that could be, this can have different wording here. It could be, instead of cycles, it can say vibrations. Instead of vibrations, it could say oscillations. Can say oscillations. I can't spell oscillations. Sorry about that, guys. But so this word right here, cycles, can be interchangeable. And then since your period is just 1 over your frequency, you'll see that period is just 1. Come on. Is just 1 over, again, the number of cycles. So that's one way of kind of looking at it. So oscillations, vibrations, cycles, all of those words are interchangeable. So let's look at our example here. So a strong wind can apply a significant enough force to tall skyscrapers to set them into a back and forth motion. The amplitude of these motions are greater at the higher floors and barely observable at the lower floors. It is said that one can even observe the vibrational motion of the Sears Tower in Chicago on a windy day. As the Sears Tower vibrates back and forth, it makes about 8.6 vibrations in 60 seconds. Determine the frequency and the period of vibration of the Sears Tower. So we want to do frequency and we want to do period. So if we're kind of doing our guess method here, so let's pull out our givens. So we're given, so our vibrations, I'm going to put just a vib for right now. Our vibrations is equal to 8.6, and our time which would be nice if I could write a T right now. There we go. Maybe we can actually, right? So time is 60 seconds. So that's where these number of cycles over 1 second comes into play. So our unknown is frequency and period. So our equation, let's do our frequency equation. So that's when we do number of, in this case, we're looking at vibrations over our time. Now we specifically want 1 second, but you can simplify. So we just do 8.6 over 60, once you divide that out, you take your handy dandy calculator and divide that out, you are figuring out how many vibrations are in 1 second. So in 1 second, it's doing a 0.4, your frequency is 0.4 in 1 second. So that hertz is basically vibrations over seconds. So that would be your frequency. Now, to solve for your period, you can either just there's two different ways you can do it to solve for your period. So to solve for period, you can either do just 1 over frequency, which would be 1 over 0.14. You plug that in your calculator. You get 7.14, and remember that's in seconds, your period's in seconds. Yep. And then, or you could do the time, that should be T. You could do the time over your number of vibrations. So it'd be 60 over 8.6. And you should get, if not the exact same answer, close to it. And you got 6.98. So there is a little discrepancy, and it could be how I rounded. If I do 1 over the non-rounded answer, which is 0.1433333, I get the exact same answer here. So this one's different because I rounded here. If you don't round, you get the exact same answer. But you could do either way, and it works. So that's how you find your frequency and period. Let's look at the next question. So Mia is rocking to her favorite radio station, which is 102.3 FM. The station broadcasts radio signal as a frequency of 1.023 times 10 to the 8th. The radio wave signal travels through the air at a speed of 1.997 times 10 to the 8th meters per second. Determine the wavelength of the radio wave. So radio waves, you'll find out, are light waves. I know it's weird. You're like, but it's sound. It's radio. There should be sound. Nope. Radio waves are actually light waves. That's how they're able to go from all over the world. It's because they're light waves, not sound waves. But again, so let's do our givens. So we are given, first we're given in the FM. That is not necessarily useful to us because we want our frequency in hertz. So we're given that our frequency is 1.023 times 10 to the 8th hertz. And then we're saying the speed, so our velocity, is 2.997 times 10 to the 8th meters per second. And we're looking for our wavelength. So our unknown is our wavelength. So our equation is just going to be wavelength equals frequency times velocity. Or velocity times frequency, whichever way. So if we substitute, get 1.023 times 10 to the 8th times 2.997 times 10 to the 8th. Now remember, there's got to be a special way to plug it into the calculator. You want to put those parentheses, and you want to do 1.023. Remember to do the capital E if you have your if you have a graphing calculator. If not, you can always use Desmos, and it should work. But you do want to put those parentheses around there. You could do it with me and just completely mess up. Oh, it's not an extra. There we go. And so you get that your wavelength is 3.07 if you round times 10 to the 16th. And that's going to be meters. So that's a pretty big, you'll realize that your wavelengths are your biggest light waves out there. So that's pretty big. So that would be our wavelength. So hopefully that kind of helps on how to figure out your wavelength and how to maneuver around your frequency, and period. If you have any questions, again, don't be afraid to ask Miss Heath or Miss Verona. Have a wonderful day. Bye.